Okay, I hope it's still visible. I don't know why. Anyways, so now we're going to be calculating the coordinates of calculating the coordinates of EC1 when we're coming from PI1, and then when we're also coming from PI2. How do we go about this? So our bearing, which is theta 2, goes in this direction like this, which means our bearing from PI1 to EC1 is the same as theta 2, and we calculated theta 2 in step 1, and then we found that theta 2 is equals to 260 degrees 15 minutes and 11 seconds, and then our D is equals to, since isn't we're coming from here to here, what is this distance? This distance is equals to T, since these two sides are equals. So our distance here is the equivalent of T, which is 116.435. And then we substitute in the equation D sine theta, which is our D is 116.435 sine, our theta is 260 degrees 15 minutes and 11 seconds, and which means that our change delta y is negative 114.754, and then our change in x, we come here and change this sign and make it cos. Our change in x will be equal to negative 19.712, which means that our y coordinates of EC1 are equals to negative 22,406.315 plus a negative 114.754, and the answer is a negative 22521.069. And then for our x coordinates, we say 35,203.148 plus a negative 19.712, and the answer that we get is 35,183.436. Now we found the coordinates of EC1 when we are coming from PI1. So now we want to find the coordinates of EC1 when we're coming from PI2. How do we go about that? We find the back bearing. Isn't this is the forward bearing, which is theta 2, and then the back bearing when we're moving from PI2 to EC1, we say the forward bearing, which is 260 degrees 15 minutes and 11 seconds minus 180, and then the answer that we get is going to be, so which means here what we have for the value of theta here is the back bearing, so the answer is 80 degrees 15 minutes and 11 seconds. And then what's our D? Our D is the distance from here to here. How do we find that? We say the whole D, this one, the whole distance, which is D2, it's not D1 anymore. D1 is this one. D2 minus the tangent to get this small distance. So what's our D2? Our D2 is equals to 5239.027 minus T1, which is 116.435. And the answer that we get is 5122.59. 2. And then we do exactly what we were doing, d sine theta, d cos theta. So our d is 5122.592 sine theta, 80 degrees, 15 minutes and 11 seconds. And this answer is going to be 5048.648. And then our dx, we just come and change this sign and make it cos. And the answer that we get is 867.239. And then what are the coordinates of EC1? We said this one, negative this, plus the positive this, and then positive plus positive. The answer that we get for this one is going to be a negative 22521.069 and 35183.436. Now we found the coordinates of, sorry, did I move too fast? I'm sorry, so that you can see it also. Right. Now we found the coordinates of EC1 coming from this point, and then the coordinates of EC1 coming from this point. Now the last step that we're going to do is finding the coordinates of MP1 coming from this point, and then MP1 coming from this point.